In this video, we will look at a broad outline of data mining process. So data mining process starts with data preparation. So we will be covering these data preparation steps in the next couple of chapters. So data preparation here represents cleaning the data. So data will have, typically the data that's coming in may have some errors, some typos and things like that. So how to identify erroneous data and how to fix those erroneous data in an efficient manner. And then data visualization is used to understand the data. And maybe some data may need to be modified or transformed because of the shape of the data. So data visualization is a tool that we use to understand the data in order to make transformation or in order to make decisions about whether transformations are needed, and if so, what kind of transformations. Dimension reduction is when you have lots of predictor variables, lots of independent variables, and it becomes kind of difficult to manage that many independent variables. And when you have lots of independent variables, there are problems that arise called multi-correlation. We'll talk about multi-correlation when we get to that chapter. So sometimes it is a good idea to transform these hundreds or even thousands of variables into a manageable set of only about 15 or 20 variables, for example. So this process is called data dimension reduction. So we'll talk about dimension reduction. So once that is done, once the data is ready, then you can use it for supervised learning or unsupervised learning. So as I said in the previous video, supervised means you have a specific target to predict. So you can have prediction. So in the prediction models are like when you have a variable, when you have a target variable that is continuous. So for example, customer, how much, what is the dollar amount that a customer will spend in a particular sale event. So that would be a value anywhere from 0 to maybe, 1,000, 2,000. So it can be any number. So you try to predict, and there are several models that we can use to make that prediction. So that is called predictive model. Then classification is when you classify a customer into 1, 2, 3, or it's just a handful of groups. And typically it will be only 2, like for example, good credit or bad credit. Or if you send a sales promotion, whether the customer will make a purchase or will not make a purchase. So that will be a 0 or 1. 0 means no and 1 means yes. So these are classification problems. And again, we can use classification methods. And you will notice that the same methodology name is used both places because some of these methods can be used for both continuous target and a binary target or a nominal target. Nominal meaning there are just a few possible values for that variable. So you can use, if the target is a continuous variable, then you use prediction. If the target is binary or if it is nominal target, then you use one or more of the classification methods. If it is a time series, like sales over time, and then you want to forecast into the future, then you use time series methods. And time series forecasting is covered in a separate class. So we will not be covering this. So there is 3660, I think, where forecasting is covered. So we'll be covering these two. And then unsupervised will be association rules or cluster analysis. Association rules will be like if you buy milk, and then what else will you buy? That kind of stuff. There is a famous joke that if a man buys diapers, then he will buy beer or something. So that's the association marketing association rules. And cluster analysis, kind of a segmentation, segmenting customers into different groups. So those are unsupervised because there is no particular target that you're trying to predict. And the main idea in unsupervised cases is just to derive insight into what is so special about different groups. So once the analysis is done, then you do a performance evaluation, which allows us to select a particular model or a combination of model in case of ensembles. And then you deploy the model that is deploying here means using the model with the score data to actually come up with predictions in production.